fact that we have talked about what light is and that light is made of colors, we kind of already know where color comes from. If light is made of color and all of those together put together makes white, it makes sense to talk a bit more about color specifically. As mentioned previously, light is part of the electromagnetic spectrum. It works like a wave. It has high and lows. A gap between each high is the wavelength. How often they happen within a second is the frequency. In other words, these are the waves, right? These are the highs on top here. Let me just make sure we looking at the same thing here. Let's get it down like so. Maybe red. I'm just gonna paint it over. So these are the highs. These are the lows, right? The gap here between each of the highs, that's the wavelength, right? Now, how often they happen within, for example, a second is the frequency. So this is a high frequency because this happens more often within a second compared to this frequency over here, right? So that's basically what I'm talking about. So light is therefore the only electromagnetic spectrum that we can see of all types out there, such as radio waves or microwaves, right? So we don't actually see radio waves or microwaves. There might be some military technology out there that allows us to see it, just the same way we can see infrared and X-ray and gamma rays, depending on technology. But in that spectrum, we obviously have the violet, the indigo, the blue, the green, the yellow, orange, and red. Now, the reason it exists is because of our brain and eyes. In reality, it is just electrical impulses being sent to the brain. So our cones in our eyes is responsible for the color we see, and it is most sensitive to red, green, and blue. While the rod is responsible for things like shape, light, and darkness, but they only see black and white. That means, let me just drag something over here. So basically what that means is sorry, the cones, they see the color, the rods only see black and white. So the rod is responsible for shape, light, and darkness. So without the rod we wouldn't necessarily see the shape or the form, and without the cones we couldn't see the color of those shape and the form. Okay, so since we are more sensitive to blue, and during less bright environments such as night we see more blue than any color because we are very sensitive to the color blue. That is why when we work with lighting and color we can't trust everything we see. Thus understanding color and how it works is important. If you ever tried optical illusions, you would know that our eye would trick and adapt according to what we see. That is why it is important to learn about color wheel, color schemes, color temperature, and all these things related to color, as when they put next to each other, they change and we see things differently. So to give a quick idea of what that actually means is, this is a scene I'm working on, just on the side, and it's Thomas Wright who gave me his scene for lighting. It's a part of a side thing I'm doing, but it's a good example because in this example it's supposed to be a moonlit scene, but notice all the green. Now that's because blue, when it hits orange, becomes type of green. So the color of the material and the color of the light, they're being mixed together. So I would have to change it and color correct it to get still something of a desirable effect. Now this is of course not finished, but it illustrates an issue that does arise on a regular basis, and it is important to be able to understand these things. So we'll move on to the next videos. So thanks for watching. To continue understanding lighting, we also need to understand a little bit about what we call color temperature. Color temperature is measured by Kelvin, and that is how we also can know the real life color of something in real life. Warm white tends to be 2400 Kelvin to 3000 Kelvin. bright white tends to be 3000 to 4200 Kelvin, and daylight tends to be 4200 Kelvin to 6500 Kelvin. That is a simplified explanation of what Kelvin is. It's the color of light. It is not the physical temperature. In other words, we're not talking about how hot the light is. Okay? So take, for example, candle flame has around 1900 Kelvin. 1900 Kelvin, so it's really orange and red. 1900 Kelvin. Sunlight, such as sunrise or sunset, has around 2000 Kelvin. Some of these images will show you the color as well. So in this case, this is 2000 Kelvin. Different household bulbs, they have around 2865 Kelvin. Different type of light, such as tungsten lamp, will have around 3200 Kelvin. Fluorescent light can have between 3200 up to 7500 Kelvin. 3200 up to 7500 Kelvin. In other words, this one can be as well as blue, green. Early morning or late afternoon sunlight, they have around 4300 Kelvin. Noon sunlight has around 5000 Kelvin. Daylight has around 5600 Kelvin. Overcast sky is around 6000 to 7000 Kelvin. Summer sunlight has around 6500 Kelvin. And skylight has around 12,000. Should be 12,000 here, not 1200. So 12,000 to 20,000 Kelvin. So in the context of the Unreal Engine, let's try again. Let's make it easier to look. So this would be the color of the candle. So that's 1900. And if we were to have as well as sunrise or sunset, it would be 2000 Kelvin. So not that different, but still there is a difference. If we went for a household lamp or bulb, it has around 2865 Kelvin. If we would to have a tungsten lamp around 501 kilowatt, it would have a 3200 Kelvin. So that would be around this one. I mean, you can see there is a difference. If we were to have fluorescent light, which can be between 3000 to 7500, you will have, for example, this is 7500, which means it's closer to blue and white. It's above white towards blue. If we have a tungsten lamp, which has 2000 to 10,000 kilowatt, different heat basically, you would then end up with 3275 to 3400 Kelvin. So that's 3400 Kelvin. If it was early morning or late afternoon sunlight, you would end up with 4300. So that's how it looks. If it was noon sunlight, that would be around 5000 Kelvin. If it was during normal daylight, we would have 5600 Kelvin, which is essentially white. if you had overcast sky, you would have between 6,000 and 7,000 Kelvin, so going more towards blue because there's less yellow sun coming through. If you have summer sunlight with the blue sky, you have around 6,500 Kelvin, which is essentially white. And if you just have skylight, you have around 12,000 to 20,000 Kelvin, so you have lots of blue. So these are some of these in Unreal Engine, which is essentially the same as in the Photoshop. The way you do it and measure it essentially is when you drag out, for example, the spotlight in this case, create the intensity, the light color stays 0, click use temperature, and you will get the temperature you need. It's very subtle. That's basically what you can use to replicate the color temperature. The reason it's important also to understand color temperature, especially if you do photography and look for references for your lighting, is the fact that if you go into a room and that room has a different color, or if you go outside and it has a different Kelvin temperature, you should be adjusting your white balance to balance that color. In other words, if you don't understand color temperature or color balance, you might do something that ends up with a different color. That's why when you have different, let's take this for example very quickly and remove this one, and I will add, let's see, and I will go to search classes, and I will go to post-processing volume, and I will make sure it's infinite extent, so it goes all over the level. And if I then go into white balance, you can see that the color changes according to the white balance, which affects the whole scene. But as I do it, you'll also know that they still have a different Kelvin temperature to it, even though I'm trying to balance it out, and I can use tint to do it as well. Understanding color balance means that you understand that the overall scene might need to be color adjusted to get the proper white in it. If you look at here, this isn't necessarily white, so I might adjust it to get a more gray and white to it. The same goes if I go to global and I desaturate it, this all becomes white. The value is the same. If I increase the saturation, you'll notice that the color starts popping up, and it's even more clear what the difference of value is. And then you might use white balance to kind of get a more balanced color out of it. So that's why it's important to understand color temperature and color balance, so you're easily able to process your colors at the beginning but also at the end of your level lighting, so it looks correct. And that's because if you look at different type of lights, so if this was a photograph and you were using a camera, but when you were looking with your own eyes, this one was more green or blue. Unless you had color calibrated your camera or even your monitor, you would not capture the color because you didn't consider the color balance between the technology you're using and what you're actually watching. That is the basic understanding that you should practice and sit down and understand to understand color temperature and color balance. See you in the next video. Subtractive and additive colors. When doing traditional art, we learn about subtractive color mixing, which is different than additive color mixing. So the left side is subtractive and the right side is additive, right? But we need to learn both to truly understand how it relates to lighting and how color works. The reason we call it subtractive is because mixing colors together will produce a darker color instead of brighter. The process of color and how they came to be is very long, but what is important to know is that after a while we figure out that we only need primary colors to create all of the other colors. These primary colors are red, blue and yellow, right? Red, blue and yellow. And you might see that, but Amit, it's not on this example. Well, they aren't maybe not mixed together, and I'll get to that. So what happens is if you mix two of these together, you end up with a secondary color. This was the basis on what we refer to as color wheel. It is basically what shows what color you get when you mix two primary colors. So it used to be red, blue and yellow. So there's a slight issue here, is that in the earlier days we couldn't actually make accurate colors. So the color red, blue and yellow isn't accurate anymore. Over the course of history we have managed to develop better colors that are more pure. So that's why eventually we changed the color to cyan, magenta and yellow. So cyan, magenta and yellow became eventually the new one because these colors create more hues than red and blue and yellow would. So cyan, magenta and yellow can create all the colors in the rainbow. This eventually changed our color wheel to this concept. So what's interesting though is that the new color wheel, the secondary colors are, as you might have noticed, red, blue and green, while orange and purple are called tertiary colors, meaning that they are the third level of colors. That might be why that in the paintings before the 20th century the color schemes looks a bit odd and different, because they used to be different because they used a different color scheme, they used a different color wheel and logic. So unlike subtractive color though, additive color is what we will eventually use more. That is the color red, green and blue as primary colors, and cyan and magenta and yellow as secondary. So the way we use the color in lighting is additive, and that means that when we add color light, it gets brighter or lighter. So when we combine all colors of light, it becomes white. But you can also combine two opposite colors on the color wheel to get white. In other words, the relationship between color is inversed in additive color in comparison to subtractive color. We'll talk more about that in the next couple of videos. See you soon. So far we know that the left side is subtractive color mixing and the right side is additive color mixing, and we know we use the right side when we do lighting, and that color, when they light together and it's mixed, it gives a new color, and that is one of the reasons we need to understand what happens when color mixes. Now there are different kind of color models. For this particular video we will talk just briefly about the RGB model, red, green and blue. We use this model a lot when we do lighting, in which we know that 0 means no red or green or blue. So any number of 1 in red, green or blue will create one of the colors. So if I do 1 on the red, it should create red. And if I do, actually this one is actually on 250-50 range, so I think it has to be 250-50. So different type of RGB models have different range. So some will have 0 to 1 on Photoshop. It happens to be 0 to 255. So in this case it's 255 that's red and 0 is nothing. So if I go 0, it goes back. So if I go to green, do 255, that's green, right? And the same goes for blue. Go 255, it's blue, right? So you might be wondering, okay, but what if you don't go all the way? Well, of course, that is possible. So if I just write 150, I get a different value of color. Right, so go to 0, we get another one. If I go to 10, I get a different one with a different brightness, so to speak, within the red hue. So the reason we need to understand this is because we need to know when some colors are off or ends up being different. So remember that color mixing using RGB allows us to know what to tweak to get the desired effect. The SMYK, which is this model on the left side here, works in a similar way, but in lighting we mostly use RGB, if only RGB. But you will probably notice me using SV, HSV or HSB. SMYK is on this side, so you can see if I change the numbers here, it obviously changes the number everywhere else. So it's 75% of cyan, 68% of magenta, and 67% of so if I start playing around with it, you'll see that it changes the color and everything else. So there's different way of doing things depending on what you choose to use, right? We'll use RGB and HSV. In the next video we'll go through HSV, which is similar to HSB, the one above here. There is another color model called HSB or HSV. In Photoshop it's called HSB, hue, saturation and brightness. In Unreal Engine it's called HSV, hue, saturation, value. So the hue represents, for example, a color, blue or green, and it's either represented by 0 by 1, or in this case by 0 to 360, which means any number between these two values represents other colors, as in changing the base color to, for example, royal blue to dark blue or light blue. So the saturation refers to the amount of gray added to the hue. In other words, if you add 0 to the hue, it will disappear and become gray. If you add 100%, it will have full saturation. So, for example, there's nothing, and then there is color. So it's white, and color, white, and color, white, color, white, color, white. So although we are using V for value, that is the lightness in other models. So there's another one called HSL, which is the lightness. So simply put, lightness refers to how much black or white is mixed into the color. In this case, 50% it is pure color, 0 is black, and 100% is white. So in this case, 0% is black, and 100% is color, which means white. That's the difference. No color, so basically it's black, and then you have certain dimming effect to it. I personally do use value these days because it gets rid of some of the brightness that might occur, so I might dim it down to a certain value. But it's the same as say if I do go on a value like this, right? It's the same as going down like this, more or less, right? It's a slight difference. So we mostly see value, which is related to lightness, mentioned earlier, but it refers to how much the hue of your choice is mixed with only the black. So the lower the value, the blacker it gets, thus the darker the color becomes, right? This is the slider for it, and this is also the slider for it, right? So the luminance is the brightness of the color we see. That means the different colors have different brightness to it. Naturally, white being the brightest and black being the darkest, which means gray is in the middle. However, every color has a certain amount of brightness to it. To see the difference in luminance on color or light, we use grayscale images to see it. So value, as I said, can also work as is basically the luminance, right? And if I do like this, not sure if I have. Nope. So let's just quickly add in a post-process volume and turn on infinite, and I'll turn the saturation globally to 0, so it's now black and white, right? Do a key light, and if I go here and do this, you'll see the brightness, the luminance is changing, right? Which again is the same as more or less doing this. And this is what we talk about when we talk about shape and form. So the reason to understand this is basically how, why, or what the bounce light that is being reflected should be, what the key light should be, what the rim light should be. If the light that is being cast is not pure white, the reflected bounce light on the surface that is green will not reflect green, but the colors will mix to another color, as shown earlier. If a blue light is being used on red apple, it will often become black in real life. So if your light is pure blue and have pure green and red materials, it will often disappear. So things happen basically due to the material, and that's quite important to keep that in mind when you're doing your work. And often when you have black and white, you can look at it and then you can turn on the color and you can get an idea of what you need to adjust. Now, so a quick fix for now, for example, would be maybe to dim the colors to be desaturated to see if that looks better, right? Or I might go in here, work with the color balance a bit to make it even more grim and realistic, so to speak. So there's different ways of making this work to your favor. So that's it for this video. Thank you for watching. Color and tone is also something that is important to understand. But to start off, we need to understand the meaning of color a bit more, just briefly, before we go even more in depth about it. So, in Western countries, at least, we associate with colors and think about it differently than in other countries, right? So, for example, if you would take the color, let's say you take the color something on red. Now, red is often considered dramatic and evokes kind of eroticism, danger, power. If red is mixed with other colors, it can have the opposite effect, right? Depending on the type of color you choose. You can see this has red and blue. If you go for orange, it's considered to be stimulating and often related to, a type of sunset. So it might look like, okay, he's out and there's a sunset going on. Yellow is often considered to be positive color, such as happiness. If you change the tonal value of it, though, it can become unpleasant as well, right? So if I wanted to, I could, try a different yellow, different hue, and it then becomes a bit different. Green is often associated with nature, because we have green around us on Earth, so it can be in healthiness, it can relax us. But again, as with any green, depending on how you use the green and what tonal value you choose, it can have a different feeling, right? If you have a very super green, might look very sick and toxic. If it's maybe desaturated, it might look a bit like dying or old, something like that. Cyan is often a sci-fi color, often used in fantasy settings as well. It's bright, it's an energetic color. We often use cyan color on villains to give them a more of a evil kind of menacing look. Blue is often associated with peace and tranquility, but at the same time it is used to represent sadness, cold, or evil. So again, it really depends on the type of tonal value you go for and what it does. we often use it for night scenes, right? So if you want to represent like it's night, we go for blue ones, right? Purple has been considered majestic or mysterious, typical royal color in the ancient times, due to the dye being expensive. Often used for spiritualism, wisdom, magic, and so on, right? The movie Avatar used a lot of purple type of colors. All of this is good to know because the saturation, the value, the cultural representation, and many other contexts. Take red, for example. In Indian culture, the bride wears red. Traditionally, in Christianity, in Italy, the Pope wears red, and it represents devil as well. Take black and white for the matter. Black is used for in funeral in most Western countries, but in India, it's white. So how we react to color depends on the whole context and situation, the relationship with each other, the color, the story, the character, the scene. All of these matter, right? All of these things matter. So understanding that is a good idea, so you can make the right choice and decision for your scene. So that's it for now. Thanks for watching. Since a single color alone shouldn't be analyzed, one must understand how multiple colors work with each other. Take a complementary color scheme, which means the color opposite of each other on the color wheel. Such as a combination will create strong visualization. So you can see these are complementary at any given time, and thus they create a great contrast. Bright green and bright red, for example. Now, this can be used in different combinations, such as visual difference or chaotic or disturbing if they were in high saturation. The reason for that is value, tone, and intensity. In other words, they are competing for attention if they are same in saturation, despite being different colors. For example, look at this bright red and bright green. They're so bright they are technically competing with each other. If you move them around, you can see again green being quite bright here, and you have the bright purple here as well. It's competing for attention, right? So knowing this is important. So if you go to a room with a children room, look at the children toys, or look at the most animation movies or children games, you'll find that the primary colors are used a lot to create a happy and positive mood. On the opposite side, you have a monochromatic color, which uses one color with different tonal value. Or analog color is another one. An analog color uses the color adjacents on the color wheel. What this does is creates either a more stable mood, such as peace or feeling of sadness. So it is possible to take strong complementary color scheme and desaturate it to make it feel empty and dead. So if I go to the monochromatic, I can play around and see what different color schemes or color palettes, if you may, that I like, that creates the mood I need. Knowing color theory, this will obviously speed up the process, right? Or if I want to have an analog one, it's picking everything next to it, so I can move it around and just make an analog color scheme within the same color. That's also possible. And I can, desaturate it or change the color altogether. So there is an analog, which are 3 or more colors side by side on the color wheel. There's the split complementary color, in which you pick one color and then 2 other on the other side next to the original complementary color scheme. That means, let me go to complementary, custom. That would look something like this. Okay, in other words, split complementary means if this is split complementary around the blues, you could kind of say that what you're doing is you're splitting up, you're not picking the one in the middle, kind of. Double complement is when two sets of complementary colors are next to each other and a cross on the other side of the color wheel. So it's more of an X. So it would be kind of like something like this. And you have more, like a tetrad is a combination made of 4 hues with equal distance. You have dyad, which is when your colors are apart, but you're skipping one in between. And you have the triad, which is equally spaced from each other as a triangle. So there are many different color palettes and color schemes you can go for. There's compound as well, and then of course there's different shades, which basically is different saturation to your color, which creates the different shades. So that's an interesting example as well, because it shows what you can do with just saturation. So knowing the color theory and the colors, and also color harmony, so color.adobe.com is a good place to do that. You can also go explore and see what other people are doing as well. So that's kind of useful, I think, to get an understanding of different color palettes. And that's it for this video. See you on the next video. So to connect some of the dots about color and saturation and brightness and value. So light obviously have value, but it doesn't matter what color you have, what intensity and brightness of the color you have. When light hits an object, it will create different value in real life. Those values go from light to dark, which creates the form we see. In other words, let's see if this works. Yep. Okay. So if you ever learned drawing, you might have heard about the range of values, which often goes from 1 to 9, from the lightest white to the darkest value black. When we manage to light based on how real life value works in our surroundings, we are able to create more realistic or believable images. So understanding value means understanding light and shadow, which in return means understanding form, but color matters as well in this complex equation. So normally when light hits an object, for example a sphere, it will create direct light, a highlight, halftone, core shadow, reflected light, cast shadow, and occlusion shadow. So there's a direct light coming from here, the highlight is here, and it often represents the reflection of the light source. Halftone is the how should I explain it? It's the gradient from the light to a darker area going towards the core shadow. So in this case, this area here, you can see it's going this way and it's darker compared to this area, which is brighter. That's the halftone. The core shadow is this area here, which is suddenly, you can see it becomes dark. That means that light is no longer entering in this area. And reflected light is this light here, which is coming from hitting the surface. In this case it's green, and the material should be green, but this one is faked. And then there's the cast shadow, which is the shadow from the object. Of course you have the rim light in this case as well. So different value will create different illusion of volume and shape when you do lighting. We have something called achromatic value scale and chromatic value scale, which essentially means that it's black and white in color. I believe I have slide here. So that's the value scale, and that's the chroma scale. So that is the achromatic value, and this is the chromatic value. So now you might think that we all have to just slide the value in the color picker. That's not how it works. When we do lighting, we use lumens, candles, lux, or intensity. That is why learning to see the value and interpreting it is important. For example, here you will see that this example it's quite bright in this area, right? There's a lot of highlight and it's starting to burn it out. So what we do instead, we pick the hue as in the color, and we adjust the saturation and the intensity as they affect each other. After adjusting saturation, we often have to adjust intensity to get the value right. I do often adjust the value though in my lighting, because I personally think it's a better way of reducing highlight and get better fall off gradient details on objects. But I do have to increase the intensity a couple of times more if I do that. And because light and value is linked together, having two lights over each other with two different colors means it creates a new color, right? It creates a new color. So you have a bit orange, and then you have green, and you have red and blue. So mixing them together will have different effects, right? So colors, although with the same hue, saturation, intensity, next to a different color will look different despite being exactly the same. So knowing the color code and knowing how the relationship between color works, the color harmony, and even contrast is quite important. In this example here, you can see I've lit up an area, and it's 3 colors, right? It's, if I were to show you what I did, it would be a triad. So essentially something like this, right? This color palette. And you can see that even though that's the color palette, it still looks different and it feels different. So in one area you have this orange type of color, in other areas you have a blue color, then you have the purple color, and then they are reflecting and bouncing around and kind of creating specular effects and highlights and so on. And that's why you need to understand color, because then you can do the adjust. Now, hypothetically, if I were to just gonna reduce the quality down a bit quickly, and I'm just gonna find my this is my purple space light, which technically is my key light, but it's not really in this case. So if I were to go in here and pump up these a bit, and then do a quick light build, if you pay attention, let's wait a bit, gonna build a light. Let me just do a quick screenshot. So now you can see it, because I increased just the saturation, but also the value in this case, it looks a lot brighter. In comparison, if I now show this one, it's darker and there's the bright one. This one has a bit more highlights. This one, although, has a different kind of color tone and value to it in shape. So if you look very closely, you'll notice that the shape and the forms are different in the areas of this image now. There's some areas that has lost some shape and some areas might gain some shape, and they're darker. So there's darkness, a lot more darkness when I did that. If I were to do this, as in make it brighter, because now I'm making it brighter, we made it darker earlier, and I do a new build, we just wait, And now you can see it looks completely different. Now, because I changed it, you can see the other lights in this room that are faked or part of a detail needs to be adjusted to match that. So there's a different intensity now compared to the last change as well. So these all affected and they all change it. Makes it flatter, makes it darker, depends, right? So it's a good idea to keep these things in mind. So light, value, color, they all matter and they all affect each other based on those things. So keep that in mind. See you in the next video, and thanks for watching. Another thing to keep in mind, because it's connected to color, light and everything, is contrast. Part of a lighter's goal is to create the mood, which is the emotion or the story you're trying to tell. This can be done in many ways. Like in the movie Blade Runner 2049, you have a certain color in the background and then the lighting, as well as a dark silhouette of the character so you can see it clearly, and it also removes any information further down the road because it's very foggy. The viewers wonder what is happening, where is it going, and so on. One other method of creating contrast is dividing high contrast and low contrast, like this game Limbo over here. You have darkness in the front, mid blur darkness, and then you have gradients in the background to create that contrast in the story. And of course you'll notice a red flower, in this case very clear information for the player that this is something useful for you. High contrast means the image uses large range of values. Low contrast means it's using limited range of values, often mid-grays. High tension images have more drama and low contrast has less drama. Horror films typically use high contrast with a dark value. This image in Horizon Zero Dawn uses several things. You can see the dinosaurs, you can see the character, the shape of the mountains, the trees. These are all visual contrasts, both in terms of lighting, color, but also intensity. The fog itself is a layer, and also of course the color choices. In comparison, low contrast tends to be cheerful, often seen in animation movies or I wouldn't say stylized games, but action-packed, happy type of games. This image is from Mario Kart. You can see the shadows are not that dark. Overall, the characters, you can see everything clearly, the environment clearly. So that's rather low contrast. So again, when I talk about value in this context, and to make sure, value is the range that goes from black to white or vice versa. And when I play with it, I am playing with contrast and turning something from high contrast to low contrast. When I do that, I can also lose details or gain detail. So you have the lightest detail here and the darkest detail here. Depending on your screen, in my case, I can't really see the whole white square. I can see it briefly, but it's so well mixed in this background. This is a good example of losing details due to the contrast. It isn't necessary that when I light I have to keep everything well lit. I can hide certain parts as well. It can be equally powerful and set the mood that I have been asked to do or want to tell. For example, just a random example is from this movie Skyfall. It's suspenseful and otherwise. You can see he has reflection in his eye from one of the light sources. It's lighting just part of the face and a little bit on the right side of the face. If you remember me telling you, it's normal that we want to see both eyes, otherwise we'd really just get annoyed and frustrated, so that's why it's lighted. You'll see the bright side here, very diffuse, spotlight, everything else is further dark, creating contrast. But you can also see the side of the face is being created contrast because the background is bright. You'll notice this left side isn't equally bright as the right side because it doesn't have to be, because this is the bright side on the face, this is the dark side on the face. Often split lighting is sometimes what I call it. If I combine all of it and create even more interesting feeling and mood or emotion in general, like this movie in Emperor, another random example, but it proves the point, is the type of colors. They are more or less within the same range and values, different intensities. It's well lit everywhere. You can see the shadows, but they aren't too dark or too bright. All of this create contrast, like this orange up here. In other words, even if you don't have more than 2 values, you can create contrast using shapes. Like in this case, to me, what catches the most attention is the sphere, because it stands out, even though there are squares there. It is the sphere, the solo sphere, which is alone, and the squares that are so many of, they aren't necessarily catching my attention. They're also smaller, but the sphere is catching my attention. So this gray background, these have the same color, black, but because of the shape, it's also creating contrast. It doesn't always have to be color or light. But in the case of color, it can be. On the left side, arguably, you might see that the red color looks darker. On the right side, you might see it looks brighter. Although these are the same values in the same red color, depending on what color you put it next to, above, and so on, it will look differently. So knowing that is very important, because it might solve you some technical issues, visual issues, so on and so forth. So that is contrast for you. See you in the next video.